Okay, so now let's do pop first. So I'll bring up our doubly linked list here, and pop first is just removing that first item. We do have two edge cases. First is if we have only one item in the list, and the second one is if we don't have any items in the list. So if you're going to code this, go ahead and pause it here. All right, so we'll start it like this, and we will start with this scenario first where we don't have any items in the linked list. We'll say if the length is 0, we'll return none. So the second scenario we have is if we only have one item in the linked list, like this. And it doesn't matter if we have one item like this or if we have two or more. We are going to need the temp variable to point to the head. We'll do that like this. And for this scenario, we're going to say if the length is 1, we'll have head and tail point to none, like that. And now let's look at what we have so far with our code. This is for if we have 0 items in the list. This is if we have 1. And now let's look at if we have 2 or more. So we'll say else, and we'll build this out. We'll bring this up. And remember, we've already set temp equal to head. So to remove that item, the first thing we're going to do is we're going to set head equal to head.next. With this line of code, head equals head.next, and that moves that over. Then we're going to say head.previous is none, which does that. We do that with this line of code, head.previous equals none. And we'll say temp.next is none. And we'll do that like this. Temp.next is equal to none. And that removes that from the list. So let's look at this code and with the rest of our code. And the only things left to do are to decrement the length, and then we'll return temp. And that's our method for pop first. We'll look at this code in a moment in VS Code, and when we do, we'll create a doubly linked list that looks like this. This way we can test all 3 of our scenarios for having 2 or more items in the list, and we'll see if pop first works in that situation. And for 1 item in the list to see if that works, and then we'll run it again to see if it works when we don't have any items in the list. All right, so let's flip over to VS Code. So there is our pop first method. This creates our linked list with the values 2 and 1 that we just saw, and this is going to print that out. So let's run this. And that prints out our linked list with 2 and 1. Okay, so what I'm going to do is I'm going to scroll this up. And then I'm going to remove this line here where we print the linked list out. And I'm going to replace it with these 3 lines of code. And all we're doing here is running pop first 3 times in a row. Once for when we have 2 items, and then 1 item, and then for 0 items. So I'll run this, and that returns our 2 nodes, and returns none. And just to make sure this is all working correctly, I'm going to come up here and change this to temp.value, and then run this again. And that has removed our 2 node, then our 1 node, and then return none when our list was empty. And as we usually do, we're going to come up here and remove the dot value so it just returns a node instead of just the value. All right, and that is our method for pop first. Okay, let's create our get method. And get is going to look like this. We're just going to get an item at a particular index. So as we've been going through these methods, okay, let's create our get method. And get is going to look like this. We're just going to get an item at a particular index. So as we've been going through these methods for doubly linked lists, you may have noticed that some of these are essentially the same as the methods for singly linked lists. The big exception to this point has been pop, and that one's very different in doubly linked lists versus singly linked lists. Get is going to be one of those methods that we write very differently than the way we did in singly linked lists. So let's start out by actually bringing up a singly linked list and walk through the steps that we went through to make this work in a singly linked list. First, we had to make sure our indexes were, in this case, 0, 1, 2, or 3. We couldn't have anything out of range on this end, and we couldn't have anything out of range on this end. So we would say if the index is less than 0 or greater than or equal to the length, then we're going to return none. This is going to be the same in a singly or doubly linked list. So let's bring up our linked list here. And what we did is we set temp equal to head like this, and we'll remove head and tail. And we created a for loop to go until we got to the index. And we would move temp forward by saying temp equals temp dot next until we got to the index that we were looking for, and then we would return temp. So this was our code for the get method for a singly linked list. And it just so happens this all works just like this for a doubly linked list. But in a doubly linked list, we can optimize this. So let's bring this up, turn this into a doubly linked list, and look at a couple of scenarios. First, let's return the item at the index of 1. In this situation, we're going to start at the head, and we're going to iterate through until we get to that index, and then we can return that node. But if we're looking for the node at the index of 2, it would be more efficient to start at the tail and go the other way. It's closer to tail than it is to the head. So if we're going to optimize this for a doubly linked list, there are some changes that we need to make. So let's bring our code back and make our changes to this code. So you only want to do this for loop here if the item you're looking for is in the first half of the list. So we're going to say if the index is less than self.length divided by 2, in other words, it's in the first half of the list, only then do we run this for loop. So if it's not in the first half of the list, it's in the second half, obviously. So we'll say else. And let's shrink this down a little bit here so we have more room. And the first thing we need to do here is set temp equal to the tail. In other words, temp was here, but in this situation, we need to start here and move backwards through our doubly linked list. Then we need to create a for loop that's going to start at this point and go backwards. And we do that like this. So what we saw in the other for loop is we just passed it an index. But what you can also do with a for loop is you can tell it the number where you would like to start. In this case, the length minus 1. In other words, the index of 3. Normally, when you have a for loop, you just want it to increment by 1 every time you loop through. In this case, we can tell it to decrement by 1 every time we loop through. And as we do, we'll say temp equals temp dot previous, which is going to move that to the left. And once we get done running through our for loop, we'll return temp, which will return that node that we're looking for. So let's look at this with the rest of our code. We'll look at this in a moment in VS Code. We'll create this doubly linked list, and we'll run the get method at the index of 1, which will return the value of 1. And then we'll run it again at the index of 2, which should return the value of 2. But this is going to test to make sure that our code is working that goes backwards through our doubly linked list. All right, so let's flip over to VS Code. So there's our get method there. And this is going to create our doubly linked lists with 0, 1, 2, and 3. And then we'll print this. And there is our linked list with 0, 1, 2, and 3. All right, so I'm going to scroll up here. And I'm going to replace this print list down here. And then we're going to get the item at the index of 1. And we're going to get the item at the index of Okay, let's do our set method. And remember, set is actually a key word in Python, so I called mine set value. We pass it an index, and then we change the value of the node at that index. So if you want to code this, pause it here. Otherwise, I will get into this. So we'll bring up our doubly linked list like this. So the first thing we have to do is have a variable that's going to iterate through this list and get to the node that we're going to change. If we're going to change the node at the index of 1 from a 3 to a 4, we have to get temp over there. And I'm just going to change this back to a 3 for now. But just like with a singly linked list, we're going to do it like this. Temp equals self.get, and we're going to pass this an index, and that's going to have temp point to the correct node. Now this code looks the same, but remember the get method is written differently for a doubly linked list. We have that efficiency where we can start at the other end and go backwards if it's in the second half of the list. So the get method is going to do one of two things. It is either going to have temp point to the node that we're looking for, or it is going to return none because the index is out of range. So we have to test this with an if statement to see is temp equal to none, or is it pointing at a node. So we'll say if temp, and you could do this as if temp is not none, temp.value equals value, the value that we pass the set value method. In this case, we pass it a 4, and that's going to update that 3 to a 4. And then we'll return true that we were able to change this. So if temp is not pointing to a node, the condition in the if statement is going to be false. We will skip that, and then we're going to return false. And that is our set value method. And this is the first one in doubly linked lists where there isn't a single line of code that is different from the singly linked list to the doubly linked list. There's a difference in how this will run because the get method that we're calling. All right, so let's have a look. And then we'll print the list again here, and this should be 11, 4, 23, and 7. So let's run this. And there is 11, 4, 23, and 7. Now let's do our insert method. With insert, we are going to insert at a particular index a new node with a particular value. So if you want to code this, go ahead and pause it here. Otherwise, I will get into the steps for coding this. All right, here's our doubly linked list. And we're going to create a new node. And when we insert this, obviously we can't have an index less than 0. We can't have an index that is greater than the length. So we'll say if the index is less than 0 or the index is greater than the length, we're going to return false. We could also insert this at the index of 0. If it's at the index of 0, we'll just return self.prepend and pass that the value, and that will put that on that end of the linked list. And then also on the other end, if the index is equal to the length, we'll return self.append and pass that the value. So let's take a look at all three of these if statements like that. And now let's look at adding this somewhere in the middle. In order to do this, we'll need a couple of variables. We'll create one called after that points to the node that will be after this one, after we insert it. And then before. These will go before and after the new node after it is inserted. Now let's create all three of these. First, the node. Then we'll create our before variable. Before equals self.get at index -1. And then after, we don't want to use the get method here because we can say after equals before.next. The get method is O of n. It has to iterate through the linked list. Whereas if you do it like this, it's O of 1. So let's add these three in with the rest of our code like this, and we'll bring back our doubly linked list. And I'm just going to take this and spread this apart so we have room for our new node to go in there. And what we're going to need to do is redirect these 4 arrows. And when we're done, we want them to all look like this. So let's put this back, and we'll start with the 2 arrows that are on the new node. We'll say new node.previous equals before. That is to say, the previous arrow on the new node is going to point at the same node that before is pointing at, like this. Then we'll say new node.next equals after. The next arrow is going to now point to the node that after is pointing to, like this. Then we'll say before dot next equals new node. And then after dot previous equals new node. And that adds the new node into the list. So these 4 lines of code redirected these 4 arrows. Now let's look at this in with the rest of our code like this. Then we just need to increase the length by 1, and then we'll return true. So that is our insert method. We'll look at this in a moment. And when we do, we'll create this doubly linked list with 1 and 3. We'll print that out. And then we'll run an insert method to insert at the index of 1 a node with the... And I'm going to scroll. That has printed out 1, 2, 3. Now let's do our remove. If the index is 0, return self.pop first. And likewise on the other end, we'll say if the index is equal to the length minus 1, return self.pop. So let's look at all three of these, and then we'll bring back up our doubly linked list. So we are going to remove the item at the index of 2, and since we're going to return that, we need to have a variable point to it. We'll use temp. And I'm going to show you a couple of different ways of doing this. One way you could do it is create before and after variables. And when you remove temp, you can say before dot next equals after. And you can say after dot previous equals before. And personally, this is how I would write this because I think it would be easier to read. But I'm not going to do it this way in this video because I want to show you a different way that you can do this. So I'm going to bring this back, and we are only going to use the variable temp. And we'll create that by saying temp equals self.get. Let's look at this in with the rest of our code. We're going to pass that get method the index where we want temp to point. Now let's bring back our doubly linked list. So I'm going to pop this 23 up here. And the way we're going to do this is those two arrows that we redirected before with a before and after variable are these two arrows. And we did this with them. We can do this by just using the temp variable. And we're going to do it like this. temp.next.previous. That's the first one. You can represent that by saying temp.next.previous. We're going to set that equal to temp.previous. And the code looks like this. temp.next.previous equals temp.previous, and that points that down here. And then we do that on the other side. We say temp.previous.next equals temp.next. And that looks like this. temp.previous.next equals temp.next. And that points this down here. And as I mentioned before, I think doing it this way is harder to read. I would do it the other way, but I wanted to show you another way of doing this. Now we need to have those two arrows stop pointing at nodes in the linked list. We'll do that like this. temp.next equals none, and temp.previous equals none. And that does this. And that removes that from our list. So we can remove our list now, and we'll decrement the length by 1, and then we'll return temp, which returns that node. So let's look at this code in with the rest of our code, like that. And we'll look at this in a moment in VS Code, and we'll build this doubly linked list, 0, 1, 2. We'll remove the item at the index of 1, doubly linked list, like that.